This video is going to cover the end of the notes from Chapter 3, Section 1. So we already covered the different parts of the quadratic function when it was graphed. Remember that the name that is given to a quadratic function graph is called a parabola. This is the quadratic form of the quadratic function ax squared plus bx plus c. Remember, the c, when it's in this form, is the y-intercept. The vertex is your h and k. It's either the lowest point, which is a minimum, or if your graph looks like an upside down U, then the vertex will be a maximum. The vertex is labeled as hk, and through that vertex is a vertical line called your axis of symmetry. Go ahead. Then we practice finding the vertex using the formula x equals negative b over 2 times a. Once we find the x value, then we plug it back in to get the y. Then you can come up with different order pairs to make your U-shape. You could use your x-intercepts, or you could plot the y-intercept and then use the axis of symmetry to find a third point. Then we related these graphs to the parent function of f of x equals x squared and how it was shifted. Both of these involve a vertical shrink and a vertical stretch. These are a reflection and a vertical stretch and a vertical compress. Then we learned the standard form. We ended up completing the square when we were given our function in quadratic form to get it into standard form. Your vertex is always your hk, and your line of symmetry is always an equation, and it's the h of the vertex, and it's x equals h. This one was already given to us in the standard form, so we just went ahead and pulled out all our information that we needed in order to make our graph. This one we ended up actually completing the square, and I also found the vertex using the negative b over 2a. And again, 7, 8, and 9, additional examples. You can watch the other video that is posted to see how I work those out. So what we're going to cover today is finding the standard form of a quadratic function. So you're going to be given a vertex, and you're going to be given a point that's on the parabola. We're going to take these 4 pieces of information and we're going to plug it in to the standard form. Everything will have something filled in except for the letter A, and we will solve for A and then plug it back into the equation. So let's go ahead and try a couple of examples. So here is my first example. Let me go ahead and give you guys a visual of what the formula is again. So the standard form is f of x is equal to a times x minus h squared plus k. So I'm going to be replacing my h of my vertex. So remember, in your vertex, this is h, this is k. In my order pair, this will be x, this will be y. So I'm going to replace h, this h, and I'm going to put it here. I'm going to replace the k, and I'm going to put it here. I'm going to replace the x, I'm going to put it here. And then finally, I'm going to replace the y, and I'm going to put it here. Because remember, f of x is just a fancy way of saying y equals. So let's go ahead and replace. First, I'm just going to replace the vertex. So y equals, I'm going to leave the a, x minus 1 squared plus 2. The reason why I just wanted to write it like this first is because after I find a, I'm going to go back to this, and then I'm just going to take out the letter a. So now let's go ahead and replace x and y and solve for a. So I'm going to get negative 6 is equal to a times x minus 1 squared. Oh wait, sorry, let me go back. I'm replacing x. I'm replacing that with a 3. And now I need to follow order of operations. So I'm going to do what's in the parentheses. 3 minus 1 is 2. Next I'm going to square the 2. And now I'll begin to solve by subtracting 2. And let me go ahead and write this up here. So then I end up with negative 8 is equal to 4a. Going to divide by 4, and a equals negative 2. I'm now going to take this a value, and I'm going to plug it into my equation again. So my final answer, my equation in standard form, is y is equal to negative 2, parentheses, x minus 1 squared plus 2. Let's try one more example. Remember, this is h, this is k, this is x, this is y. So again, if it helps to color code, this will be yellow. The x is the green. The blue is the k. And the red is the h. So let's go ahead and plug in. So y, I'm going to change the f of x into a y, equals a, and then I'm going to do x plus 4 squared plus 11. All I've replaced so far is the h and the k. Now I'm going to go ahead and replace. All right, so now I'm going to replace also x and y. So 5 equals, I don't know a yet. My x value is negative 6. I'm going to evaluate the parentheses. Negative 6 plus 4 is negative 2. And now I'll square the negative 2. Becomes 4a plus 11. Subtract the 11. Negative 6 is equal to 4a. Divide by 4. Negative 3 over 2 equals a, because I can reduce the 6 over 4. So now I'll take that a value and plug it back in. So f of x or y, I believe WebAssign wants y. So you can either write it as y equals x plus 4 squared plus 11, or you could use the f of x. X plus 4 squared plus 11. The next slide actually has information about using a graphing utility, and in this case, these would be the instructions that you could follow if you have a TI 83 or an 84. So you can just follow this instructions, and this will help you to find your zeros by using the trace feature. Now, if you have not purchased a graphing calculator yet, there are apps out there that you could get for your iPad. One of them is Desmos. And you just key in the function, and then if you wanted to find the x and the y intercepts, it'll create order pairs, little dots on the graph that you can touch, and then you can see those coordinates. Keep in mind, however, if you find an x-intercept and if it has a square root, when you touch those order pairs or those dots, it's going to display it as a decimal. When you're answering this question on a test, I want you to keep it in simplest radical form. So the next slide actually asks me to use a graphing utility. I went ahead, and this is the same question that I had solved earlier, and I believe it was example number 8. I did it by hand, but you can key it into a graphing utility and you'll get the exact same answer. These are again the steps for writing a quadratic function in standard form. So you'll be given your quadratic function in quadratic form, and then we will use completing the square to convert it to standard form. And these are the steps that you should follow. We've already previously done the examples in the first video I posted for 3.1. Now what I'm going to do is just additional examples completing the square. So here the instructions say to put the equation into standard form. Find the vertex, y-intercept, x-intercept, and the axis. So again, my first step is I'm going to take the constant and I'm going to shift it over. I'm going to make a blank space so that I can complete the square. So I'll move the -3 over. My next step is to take the b term, divide it by 2, and square it. -3 squared, I would be adding 9 into the parentheses, but over here I'm going to subtract 9. Now if you recall back when I did this in chapter 1, I like to put not what I got when I squared, but what it was before I squared it, because that makes it my factoring this trinomial so much easier. So now I'm going to go ahead and factor the trinomial, and it becomes x minus 3 squared. I'm now going to, and this shouldn't be a -3, this should be a -9. And now I can combine my constants on the end, and I get -12. And now my equation is in standard form. Remember, this is h and this is k. So my vertex is located at the ordered pair 3, -12. When you pull the h out, remember the subtraction sign in front of it is part of the equation, so it's opposite of what you would think. My axis of symmetry is always an equation. If you just tell me it's 3, you're going to lose points on a test. So my axis of symmetry is the equation x equals 3. For my y-intercept, I could go back to my original quadratic form, and it's always the c term. So my y-intercept is located at 0, -3. Recall, to find intercepts, you plug in, for example, I'm going to set x equal to 0 to find my y-intercept. Now I could either plug it in here or here, it doesn't matter. I still will get the same y-intercept. So if I go back to my original and I plug in 0 for x and I solve, I get 0 minus 0 minus 3, which gives me y equals -3. And again, remember you plugged in x equals 0. So again, your y-intercept is 0, -3. But again, just remember that when your equation is in this quadratic form, the last term, the constant, is always going to be your y-intercept. Next, I need to find the x-intercepts. So to find the x-intercepts, I'm going to set y equal to 0. And the easier way to find the x-intercepts is to use the standard form. You could go back to the original, and if it's something that could be factored, that would be the faster way probably, but this one cannot be factored. So let me go ahead and use my standard form. So again, set y equal to 0, x minus 3 squared minus 12. I'm going to add 12 to both sides. 12 is equal to x minus 3 squared. I'll now apply the square root or the even root method. Plus and minus the square root of 12 is equal to x minus 3. Now, I can either choose to break down the square root of 12 now and then move the 3, or I can move the 3 and then break down the radical. So if I go ahead and break down the square root of 12, it turns into 4 times 3. And then I know 4 is a perfect square, so it simplifies to 2 square root 3. So let me go ahead and do that. And now I can move the 3. So now I'm left with 3 plus or minus 2 square root of 3 equals x. This is what I'm going to be putting into my coordinates for my x-intercepts. So I have an x-intercept at 3 minus 2 square root 3 comma 0, and one at 3 plus 2 square root 3 comma 0. Remember always to write them as order pairs or as coordinates. I now have found everything that was requested. Again, I found my vertex. I found my axis of symmetry. I found my y-intercept. And then I also found my x-intercepts. Let's try another example. So again, same thing. I'm going to shift the constant away and leave a blank space for my perfect square trinomial that I'm about to make. I take the b term, divide it by 2, and square it. Negative 2 squared becomes positive 4. That's what I should be adding into the parentheses and subtracting outside of the parentheses. And again, for the adding part, I'm going to show that I'm going to be adding negative 2 squared. I now factor the trinomial, and it factors into x minus 2 squared. I will next also add the 2 constants, and I end up with minus 11. I now can pull out my vertex. My vertex is located at the order pair 2 comma negative 11. My axis of symmetry, I'll abbreviate that as AOS. Again, remember, it's the h of your vertex, but it's an equation, so it's x equals 2. Next, I can find the y-intercept. And remember, you can go back to the original and pull out that c. So my y-intercept is 0, negative 7. And now I have to find the x-intercepts. And again, since my original equation cannot be factored, if I were to use that one to find the x-intercepts, I would either use completing the square or quadratic formula. Since I've already completed the square, I'm going to go ahead and use my standard form. I'm setting y equal to 0, and I get 0 equals x minus 2 squared minus 11. I am going to add the 11. 11 is equal to x minus 2 squared. Apply the square root method or the even root method. Plus and minus square root of 11 is equal to x minus 2. I'm going to add 2 to both sides, and I end up with 2 plus or minus the square root of 11 is equal to x. Again, remember, it needs to be written as order pairs or coordinates. So 2 minus the square root of 11, comma 0, and 2 plus the square root of 11, comma 0. These are my x-intercepts. Okay, let's go ahead and try number 15. Again, same thing. We're going to put it into standard form by completing the square. So again, I'm going to shift my constant over. I'm going to take the b term. I'm going to divide it by 2 and square it, and it gives me 25 over 4. This is what I'll be subtracting from this side, but I'll be adding it to this side. And again, I'm going to write what I got when I divide it by 2, and it makes it easier to factor. So let me get rid of that. So I now have left with x minus 5 halves squared And now I have to do the math here. So I'm doing negative 4 over 1 minus 25 over 4. Common denominator will be a 4. So I can go ahead and change this into 16 over 4. Both of them are negative. So when I add them, I get negative 41 over 4. And now I can pull out my vertex. So I have a vertex at 5 over 2 and negative 41 over 4. So this is my vertex. Next, I can list my axis with symmetry, and it's x equals 5 over 2. My y-intercept, again, I can go back to the original. It's going to be the negative 4. So again, as an ordered pair, 0, negative 4. And now I can find my x-intercepts, and I'm going to use the standard form. 0 equals x minus 5 over 2 squared minus 41 over 4. I need to move the 41 over 4 to the other side by adding it. 41 over 4 is equal to x minus 5 over 2 squared. Get rid of the squared by square rooting both sides. So this ends up giving me plus and minus the square root of 41 over 2, and then x minus 5 over 2. I now need to get x by itself, so I'll add 5 over 2. Final answer here is x is equal to 5 over 2 plus or minus the square root of 41 over 2. I can't simplify the square root of 41, so I'm going to leave it alone. So my x-intercepts are located at 5 over 2 plus or minus square root of 41 over 2, comma 0. Now if you, not plus minus, sorry, we're going to do them separately. Minus, and then this one, you'll do a plus sign, comma 0. Now, if you prefer to write it with one fraction, you can also write it as 5 minus the square root of 41 over 2, comma 0, and 5 plus the square root of 41 over 2, comma 0. Either one would be acceptable. Let's try another example. This time we have an a that's greater than 1. So we need to divide only the variables by 2. So when I divide it by 2, I'm left with x squared minus 3 over 2x, leave a blank space, plus 1. I'm now going to take that b term, divide it by 2. Remember, dividing by 2 is the same thing as multiplying by a half. So this gives me negative 3/4. I need to square that. And what I'm going to be adding is going to be 9 over 64. So over here, now, this is where we need to remember to incorporate the positive 2. So whatever I should have been subtracting over here, the 9/16, now gets multiplied with the coefficient that you pulled out. So I'm going to be adding, and this will give me, I can simplify diagonally, make this a 1, make this an 8. So I'm ending up with negative 9 over 8. I factored out the negative 1 out of the two variables. I shifted the 4 over. I took the b term, I divided it by 2, and I squared it, and I got 9 over 4. I should be subtracting it here, but I needed to remember to take into consideration the negative 1. So I have to multiply -1 times -9/4, and it gives me +9/4. Now I have to add -4 and 9/4, and that's what I did up here. Once I added those, I got -7/4, and now my equation is in the vertex form. So I went ahead and pulled out my vertex, and it's the order pair 3/2, -7/4. My axis of symmetry is an equation. It's x equals 3/2. And then now my y-intercept, this came from back at the beginning, and I just pulled my c term. And now lastly, I'm going to find the x-intercepts by setting y equal to 0. So let me go ahead and solve this. First thing I'm going to do is add the 7/4. 7/4 is equal to negative sign x minus 3/2 squared. Divide by -1. This becomes -7/4. And then negative sign, no more negative sign, just x minus 3/2 squared. And now I'll square root both sides. Notice I'm square rooting a negative. This is going to end up giving me I square root 7/2. When this occurs, there are no x-intercepts. So I don't need to even finish. The answer for x-intercepts is none. It's going to be an imaginary solution. And I don't graph imaginary solutions. Even if you wanted to finish, you would get 3/2 plus or minus I root 7/2. So that is it for the notes on 3.1.